Hello guys, hope you're doing well. In this video, I want to talk to you how to find the domain of a functions. First, the definition of a function. The domain of a function is the set of all possible input values. These are the numbers we allow to put into the function. Okay? So, if a number is in the domain, the function can take it and give us an output. So if a number is not in the domain, the function doesn't work that input. Let me give you an example. For example, if the domain is, for example, -1, 0, 1, it means the function accept only -1, 0, 1 as input. So every x value in the mapping diagrams or order pairs comes from the domain. So the domain tells us where the function starts or which x value are allowed. Okay? And now we will examine the domain of different functions. Number 1, the domain of polynomial functions. The domain of polynomial functions is all real numbers. There are no restriction on x, so the domain of polynomial function is equal R or all real numbers. For example, if f of x is equal, for example, x to the power of 5 plus 4x minus 1, so the domain is equal, the domain of f is equal R. And if f of x is equal, for example, 4x squared plus x plus 1, so the domain of f is equal all real numbers. Okay? Number 2, the domain of rational functions. The domain of rational functions is all real numbers except where the denominator is 0. So we have domain is equal all real numbers minus denominator is 0. So to find the denominator of rational fraction, set the denominator equal to 0 and remove those values from all real numbers. Okay? For example, f of x is equal, for example, x minus 3 divided by x minus 2. So set the denominator equal to 0. So x minus 2 equal to 0. So x is equal to. So the domain of f is equal R minus 2. Or, for example, f of x is equal 5x squared plus 3x plus 1 divided by x plus 2. So first set the denominator equal to 0. So we have x plus 2 is equal 0. So x is equal minus 2. So the domain of f is equal R minus 2. Okay? Just keep in mind, when determining the domain, you should not simplify the fraction. Look at this example. F of x is equal x squared minus 9 divided by x minus 3. So if we simplify this fraction, we have x minus 3 times x plus 3. This is a conjugate identities. So we have x minus 3 times x plus 3 divided by x minus 3. So x minus 3 in the numerator cancels x minus 3 in the denominator. So we have f of x is equal x plus 3. So this is a polynomial function, so the domain of f is equal r. That's not correct, because you should not simplify this fraction. And first we set the denominator equal to 0. X minus 3 is equal 0. So x is equal 3. So the domain of f is equal r minus 3. That is very important. Okay? Number 3, the domain of the radical functions. To determine the domain of the radical functions, there are two cases. If the index of the radical is even, so the expression inside the radical must be non-negative, means greater than or equal to 0. And if the index of the radical is odd, we can remove the radical. Just determine the domain, we can remove the radical. Okay? So look at this example. If f of x is equal the cube root of x plus 1, since the index of the radical is odd, we can remove to determine the domain. So f of x is equal x plus 1, and it's a polynomial, so the domain of f is all real numbers. Okay? And if f of x is equal the square root of x, for example minus 2, and since the index of the radical is even, so the expression inside the radical must be non-negative, means x minus 2 is greater than or equal to 0. So x is greater than or equal to 2. Okay? And if we express it as an interval, we have the domain of f is equal to and infinity, including 2. Okay? I'll solve more example in the next video, so don't miss it, and see you soon.